Okay, good afternoon, matrix. Today is the second lesson. I think the first one we looked at the calculation of distance, map conversions, and also calculation of area. We are continuing with the Mapwork calculations. What we're doing today is we are going to calculate true bearing, magnetic declination, and also magnetic bearing. This is also a very important calculation that is usually found in your papers. So the first thing that you need to know is to know what bearing is. It's just a generalized method of showing position of one place to another. And it's also the measurement of direction. It's measured in degrees as well. And when measuring it, what you do, you also identify the true north that you measure clockwise direction from the true north. I'm going to use this as an example. Assuming that you've got these 2 points that are given on the map, what is the true bearing of F from H, of F from H. So you go where it says from, this is where it says from, this is where your H is. The next thing that you'll do is you need your calculator. Okay, you need to have your ruler, you need to have your protractor as well. So it's saying that what is the true bearing of F from H. Where it says from is here as H. So what you do, you're going to draw a straight line, perpendicular line like this. You identify your true north. You identify your true north, sorry. Then after that, you join the 2 points. That is your H and your F. So what the question is asking you to do is to calculate the true bearing, that is the measurement in direction of degrees in a clockwise, which means you are measuring here, from here up to there. That is the true bearing that you are measuring. Remember, you identify the 2 points first, where it says from, like I demonstrated here. This is where your H is. You draw a perpendicular line, you identify your true north here. After identifying your true north, you join the 2 points, that is your F and your H. Then you indicate, this is the A where you are supposed to measure your true bearing, that is in degrees. The next thing that you do is you take your protractor, this is your protractor, you measure from here, okay, it's a straight line, make sure that this arrow is exactly at the center, okay? So it means from here, straight line adds up to 180 degrees, okay? Remember, we need to measure up to there, which means you have also supposed to measure on the other side so that at least you have the correct measurement. So if I'm to check now from here, 0, 10, 20, 30, 40, it's somewhere at 39, which is plus 39 degrees. So if I add 180 plus 39, 180 plus 39 degrees, what is my answer? I will get 290 degrees. That will be my true bearing. What is it that you need to know? Okay, it's a generalized method of showing the position of one place to another, the measurement of direction in degrees. That's what we are doing here. You identify the true north and you measure in a clockwise direction from the true north. This is where your true north is. So it means you measure from this direction. That's how you get your true bearing. So the true bearing of F from H is equal to, this is a straight line we have measured, which gives us 180 degrees. We have also measured on the other part, which gives us 39. If you add the two, you get 219 degrees. Then from there, the next thing that you will do is we are going to measure what we call the magnetic declination. Magnetic declination. Come closer. So with magnetic declination, there's information that is shown. As you can see here, there's mean magnetic declination, 24 degrees 42 minutes west of true north, November 2016. Mean annual change is also shown here. So how do you calculate your magnetic declination? You first consider the current year, the year that you are in. Like for example, you say we are in 2024. It becomes to 24 minus what year is shown on your map? Magnetic declination. You can see here is November 2016. That's the one that you take, which is 2016. So the first thing that you do when you're calculating the magnetic declination for 2024, what you do is you find the difference in years, which is 2024, the current year, minus what is shown on your map, which is 2016. Let's see what is there now. 2024 minus 2016. what do you have? You have got 8 years. The difference is what? 8 years. So this is the difference in years. So from there, you identify your mean annual change. Mean annual change in this instance is 9 minutes westward. This is your mean annual change, which is 9 minutes westward. So the next thing that you calculate, you have identified your mean annual change, you calculate your total annual change. Total annual change. How do you get your total annual change? You multiply now your difference in years, which is 8 years, multiplied by your mean annual change, which is 9 minutes westward. If you multiply 8 by 9, you will get 72 minutes westward. Okay. So now you don't leave it like this. Why? Because you have to change it into degrees, because 72 minutes is above 60 minutes, which is equivalent to a degree. So if you convert it now, it's going to give you how many minutes, how many degrees are in 72 minutes? It's 1 degree, which is equivalent to 60 minutes. What is left there is 12 minutes westward. So your answer will be 1 degree, 12 minutes westward. Okay, that's how you calculate your total annual change. Okay, so from there now we want to calculate the magnetic declination for 2024. How do you do it? You are going to check. You are going to check now MD 2024. You are going to check on your map again. What you have is the magnetic declination for 2016. You have your 24 degrees 42 minutes west of true north. So now, in order for us to get the MD for 2024, we check what we had in 2016. Then we add our total annual change, which is 1 degree 12 minutes westward. When we add the two, 24 plus 1, we get 25 degrees 42 minutes plus 12 minutes. We are going to get 54, which is 54 minutes west of true north. That's how you do your magnetic declination. Then lastly, your magnetic bearing. Magnetic bearing is equal to your true bearing plus your magnetic declination. You are now adding the two. What did we have as our magnetic true bearing is 219 degrees plus what did we have as our magnetic declination for 2024 is 25 degrees 54 minutes west of true north. If you add the two now, that is your 2019 plus 25. What do you have? You are going to have 244 degrees. You still have the minutes there. 54 minutes. That will be your magnetic bearing. So boys and girls, the first thing, true bearing. Identify where it says from. This is your age. You do your calculations, measurements in degrees. This is what we get as our true bearing. Then from there we started calculating our magnetic declination, which is difference in years, 8 years. Identify your mean annual change. For total change, multiply the difference in years multiplied by the mean annual change, which is 72 minutes. If it's above 62 minutes, which means you change it into degrees. So you see how many degrees are equivalent to 60 minutes is 1 degree. That's why we got the 1 degree, 12 minutes westward. Then from there, we calculate the magnetic declination for 2024. We add what we had in 2016 plus the total change. That's how we got this. Then lastly, your magnetic bearing, true bearing from plus magnetic declination, it gives you this. So always when you are calculating the magnetic declination, if it's to the west, we add. If it's to the east, we subtract. But in most cases, always to the west. This is how we calculate true bearing, magnetic declination, and also